to Einstein Helps with Grade 10 Math. We are in the unit on Algebra and Number Theory, and this is lesson number 3. In this lesson, we will introduce irrational numbers and also define real numbers. Then we will see how we can convert irrational numbers into decimal numbers, or at least approximately so. Then we will see how we can write square roots as powers with rational exponents. And then we will learn how we can simplify radicals by extracting or removing perfect squares under the square root sign, and how we can apply that also to simplify radical expressions. When we hear or read the word rational, in math we think about a ratio or a fraction. When we hear of the word radical, we have to think of roots. In fact, the word radical comes from the Latin word radix, which means root. And yes, it's the same word root that is also used in botany or plant science, as a plant root can also be called a radix or radical. So a radical or a radical number is a number that's expressed with a root sign. Examples of square roots are square root of 9 and square root of 10. But there's a big difference between these two radical numbers. Square root of 9 has the same value as 3, and 3 is a natural number. The square root of 10 can be approached approximately as a decimal number, but it is totally different. We cannot even write it. Also, we cannot write it as a fraction. Square root of 10 is an irrational number. Remember what we learned about rational numbers? Rational numbers can be expressed as a fraction, or it can be expressed as a decimal number with a finite number of decimal places, or it has infinite decimal places, but there is a repeating pattern to it. The number pi is a good example of an irrational number. You can approximate it by a fraction, but it's never the same as a fraction. And when you look at the decimal approximation for pi, generated by a powerful computer, then you will see there is no repeating pattern among the decimal places. Together, the sets of rational numbers and of irrational numbers form the set of real numbers. Now, to calculate the value of an irrational number like pi to 100 decimal places, as we have seen here, is quite extreme. In daily life, we often do not go further than rounding it off to about 3 decimal places. So how do we find the approximate value of an irrational number, like square root of 2 or square root of 3? Of course, we can use a calculator. The only two things we got to watch out for is to copy the digits from the calculator carefully and to round it properly to the given number of decimal places. Square root of 2 is approximately 1.41421356237731. Now you must realize that the last recorded digit may actually have been rounded up. If we now take this number and round it to 3 decimal places, we get 1.414. The next digit would have been a 2. Since this is less than 5, we truncate it or just ignore the digits after the 3rd decimal place. The square root of 3 is 1.73250, rounded to 3 decimal places, we would get square root of 3 is approximately 1.732. But rounded to 4 decimal places, we get square root of 3 is approximately 1.7321. Notice that there was a 0 at the 4th decimal place. But since the next digit was 5 or more, we rounded the 4th digit up to 1. How can we find the approximate value of an irrational number without the use of a calculator? I like to show this by way of an example. Let's take square root of 10 and try to calculate its value to at least 3 decimal places. First, I look at the perfect squares that are approximately 10 and use this information to interpolate. That means to guess the value between the known values. We know that 9 is 3 squared and that 16 is 4 squared. And when we look at 10, we will see that 10 is pretty close to 9 and not so close to 16. So I'm taking my guess that it should be about 3.2 perhaps. So I will start with 3.2 as a suggested square root of 10. So what I do is I take the number 10 and divide it by 3.2 and find what the answer is. Now, 10 divided by 3.2, we don't like to have a decimal point in the number that we're dividing by, so I'm going to multiply both numbers by 10. So the question is essentially the same as what is 100 divided by 32? First, we know that it should go at least 3 times, so then I hit the decimal point, because 3 times 32 is 96, and that's almost 100. Take away, I'm left with 4, and now, behind the decimal point, I can write a whole bunch of zeros. I take 1 0 down, and I get 40, and in 40 I can find only one 32, so I do 1 times 32 is 32, which leaves me with a remainder of 8. I take down another 0, and 80 should give me 2 times, because 2 times 32 would be 64, and I'm left with 16. Take down another 0, you really don't have to write the zeros there, 160, and 160 is exactly 5 times 32, so that works out nice. I write down 5, 5 times 32 is 160, and the remainder is 0. So now I know that the square root of 10 has to be between 3.2 and 3.125. We don't know exactly where, but it's somewhere in the middle, so let's try the middle. So I take 3.125 plus 3.2 and find the average, so I take the sum divided by 2. So that's 6.325 divided by 2, which gives me 3.1625. 6 divided by 2 is 3, 3200th divided by 2 is 1600th, and 5,000th is 25 10,000th. So here I have my second approximation. The first one I used, first attempt, was 3.2. Remember, I did it by interpolation between the known perfect squares. This is now my second approximation, and it should be quite a bit more accurate. However, I will take it one step farther, and I will do now 10 divide by 3.1625. And again here I should multiply both by 10,000 in order to get rid of the decimal point here. Let's start a new sheet. I multiplied both the 10 and the 3.1625 by 10,000, and this is the result. It looks like I should be able to do this 3 times again. Here's the decimal point, and first I get 3. I first do 3 times 30,000 is 90,000. 3 times 1,000, 3,000. But 3 times 625 is 1875. So I get 94875. If you want, you can do long form multiplication at the side. Okay, let's see how much is left over. Okay, when I subtract, I get 5,125. Okay, here's the decimal point, so I can take zeros down after that. So here's the first 0 that I'm taking down. And you see that I'm less than 2 times. 2 times would have been 62 something, 63 something actually. So this is less than 63,000 because it's 51,000. So I can do this only 1 time. Don't forget the decimal point. I get 1, and I can just copy down 31625 and subtract to find what is left over, the remainder here. Okay, 50 take away 25 is 25. 12 take away 6 is 6. I took the 1 already, so there's a 0. So there's a, here is a 9 now, and there's a 1 left here. 19,625. Again, I can put a 0 here and take it down. Now this is a fairly big number, so if I look at 31 here, is 31 and a half about, then my guess would be that it could be 6 times, because 6 times 3 is 18, and this is 19 and a half about. So let's try 6. Okay, so I do 6 times, and if I do 6 times, what I could do is I can double the number that I have here, because we did it 3 times. So this is 3 times 31,625, so I can double that number. And if I do that, and you can do it to the side, you get 189,750. And see what's left over. And what's left over is 6,500. Again, I can take a 0 down. I get 65,000, and if I get 65,000, I can do it 2 times. And 2 times is 62,000 plus 1,250, so that's 63,250. So that's not too bad. And if I subtract that, I get 1,750. 1,750 is a very small number, because if I take a 0 down, I still have to skip this one. I put the 0, and I have to take 1 more 0 down. Now I have 175,000, and that would work, because 175,000 is not quite 189,000, and that was 6 times, so I have to try it with 5 times. Alright, so what I could do is I can write a 0 behind there and then divide by 2. And if you would do that, you can do that to the side, you get 158,125. And when you subtract that, you get this one. Alright, so, well, we already have 4 decimal places, so we really could stop here. The next one would probably be again a 5, but let's stop here. So now we have our third approximation if we average these 2 numbers, and note that there has to be a decimal point in there. So what I do now is I take 3.1625 and 3.1625 3.16205. You see that they're already very close. So if I add those up, if I divide that by 2, I get 3.32 hundredths is 16 hundredths, and 455, if I round it up, I get to 28. So it's about 3.16228. So, in other words, this is our third approximation, and because I see that the 2 is fixed and the other 2 is pretty close, so I know that I got it at least to 3 decimal places accurate, so I will state that the square root of 10 has to be approximately 3.16228, so 23. Or if I really have to do it in 3 decimal places, I should of course stop here and say this is the answer. Let's check it out. The square root of 10 equals 3.162277, and actually you can see that this is pretty close to what we got here. The 4th decimal place is a little bit off, 3.1622. And actually, if you would round it because of the 7, that would have been a 3 also. So that's good. Next, we will see that the square root is actually a kind of power, just as subtraction is a kind of addition, and division is a kind of multiplication. Pay attention. This may be a bit tricky. 5 take away 2 is equal to 5 plus negative 2 is 3. 4 divided by 2 is the same as 4 times a half, which is 2. And 6 divided by a half, how many halves are there in 6? Is 6 times 2 is 12. Now also the square root of 4 is actually the same as 4 to the power a half. Or in general, the square root of a is equal to a to the power a half. But, of course, you already had discovered that in section 1, didn't you? Now we will look at a basic property of radical numbers. First, let's check this. Is the product of 2 squares the same as the square of the product of the bases? Look here. Is 2 squared times 3 squared, the product of 2 powers, the same as 2 times 3 and then squared? Or in general terms, is the product of 2 squares, a squared times b squared, the same as a times b and then squared? Let's break this up into steps. A squared times b squared is a times a times b times b. I can change the order in the multiplication, so it's the same as a times b times a times b. That means it's the same as ab squared. Yes, it's true. Would it be true for square roots? Is the product of 2 roots equal to the root of the product of the numbers under the radical signs? So, is square root of 4 times square root of 9 the same as the square root of 4 times 9? We know that square root of 4 times square root of 9 is equal to 2 times 3 equals 6. And we know that the square root of 4 times 9 is equal to square root of 36. And it's also equal to 6. So yes, this also seems to be the rule. But if that is true, it means that we can split up a number like square root of 75 into a rational part times an irrational part.
I can factor it into a rational part and an irrational part. Why? Because there is a factor in 75 that is a perfect square, 25. And we can and like to extract this one, to take it from under the square root sign, like this. Square root of 75 is equal to square root of 25 times 3, which is the same as square root of 25 times square root of 3. And so it is 5 square root of 3. Try these. Square root of 8 and square root of 18. In the first radical, you should detect the perfect square 4 as a factor. And in the second one, 9. So, square root of 8 is equal to square root of 4 times 2. Take the 4 out, and you get 2 square root of 2. Square root of 18 is equal to square root of 9 times 2. Take the 9 out of the square root sign, and you get 3 square root of 2. This brings us to the last topic. We can easily multiply square roots, we have seen, but we can only add square roots if the numbers under the radical signs are the same. It's a bit like adding fractions. You can only add fractions if the denominators, the numbers under the fraction bar, are the same. So, square root of 2 times square root of 3 is easy. That's a square root of 6. But square root of 2 plus square root of 3, we cannot add. 3 square root of 2 plus square root of 2 works, because here it's like adding apples and apples. 3 apples plus 1 apple makes 4 apples. 3 square root of 2 plus another square root of 2 makes 4 square root of 2. But what about square root of 8 plus square root of 18? Or square root of 18 take away square root of 8. Do you remember? Square root of 8 is equal to 2 square root of 2 after removing the 4. And square root of 18 is equal to 3 square root of 2 after removing the perfect square 9. So, square root of 8 plus square root of 18 is equal to 2 square root of 2 plus 3 square root of 2. And now you can add them together because it makes 5 square root of 2. And square root of 18 take away square root of 8 equals 3 square root of 2 take away 2 square root of 2. And so we are left with 1 square root of 2.
We covered quite a bit of material in Lesson 3 of Algebra. Make sure you review things until you really understand it, and then practice. Practice the work. Try to do all the assignments, because after this lesson we will go to the real algebra. So, I hope you did well. Keep on plugging away and check your answers to make sure you're doing the right thing. Good luck now, and we'll see you later.